Hi folks, today we are going to talk about special right triangles and reciprocal trig functions. We'll start with the special right triangles. A couple things to know. There's actually only two special right triangles. There's the 30, 60, 90 and the 45, 45, 90. These trig functions you should know. They should become automatic for you. Now with that said, I'm not asking you to just run and memorize them so you can just rattle them off. I want you to understand them. But it's something that's going to come up quite a few times throughout the course of trigonometry. It's been come up pretty regularly, so it's important that you know them so that you can move through those problems at a decent pace. Okay, so we'll start with the 30, 60, 90 triangle. And here's our right angle. And if we have a, we'll call this will be our 60-degree angle, and this will be our 30-degree angle. And you have this printout as well, so you can go ahead and write right on this as I'm going through it in the video, so you have the notes in front of you. Okay. The sine of 30, if you were to put that into your calculator, the sine of 30 is 0.5 or 1/2. So if I use this as my angle, my 30-degree angle, sine, remember, is opposite over hypotenuse. And so if that's 1, then this would be 2, right, for 1/2. And you could do Pythagorean theorem to find that missing side. If you do that, you would end up with radical 3. The sides of a 30, 60, 90 triangle are always going to be in this ratio. So if the side across from 30 was 5, then the hypotenuse would be 10. And the side across from 60 would be 5 radical 3. Okay? They always be in this ratio regardless of the size of the triangle. But here's what you need to know. You need to know what each of these are. So sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. The tangent of 30 is 1 over radical 3. I'll write that over here. 1 over radical 3, but remember you can't have a radical in the denominator, so when you rationalize it, you end up with radical 3 over 3. Okay, so radical 3 over 3. So let's go to the 60-degree angle. We're going to do the same thing. The sine of 60, so opposite over hypotenuse, would be radical 3 over 2. The cosine of 60, 1/2. And the tangent of 60 is radical 3. If for some reason you don't remember these, you can always redraw this triangle and have that as sort of your little cheat. Have that little triangle in front of you whenever you need it. Okay? Let's move on to the 45, 45, 90 triangle, also called an isosceles right triangle because these two sides are going to be the same length. So if this is 45 degrees, this is 45 degrees. And let's say that this was 1, that would mean this was 1. And if we went ahead and did Pythagorean theorem, we would end up getting that this is radical 2. And so that allows us to go ahead and find our sine, our cosine, and our tangent. Tangent's the easiest one of all, opposite over adjacent, so that's just 1. Okay, our sine of 45, opposite over hypotenuse, would be 1 over radical 2. When you rationalize it, multiply the top and the bottom by radical 2, so you end up with radical 2 over 2. And the same is true for the cosine of 45. So those are your special right triangles. You want to make sure that you know them, that you're familiar with them. If you don't know them cold, at least you know how to get them. Just create your triangle and understand what's going on in those triangles. But these are things that you need to know. These come up when they ask for the exact value of something. If they ask you what is the exact value of sine, this is what they want. They want radical 3 over 2. They don't want a decimal approximation. Exact value means without rounding any decimals. This is an exact value. Okay? Let's move on to talking about reciprocal trig functions, and then I'm going to come back and talk about the whole idea of degrees and minutes that you see on your sheet. Let's talk about reciprocal trig functions. If this is my right triangle, and I have a 3, 4, 5 right triangle, right? 3 squared plus 4 squared equals 5 squared, so I know that works. And we already know sine, cosine, tangent, right? Sine is opposite. Let's call this angle theta. So sine of theta, so that's opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, so there is my, those are my regular trig ratios. We also have 3 other trig ratios, the cosecant, the secant, and the cotangent. These are reciprocal trig functions because they reciprocate the ones that we know, the sine, the cosine, and tangent. People always confuse which one goes with which. So it's really important that you understand or you know which one goes with which. It's pretty easy to say that the tangent and the cotangent go together, right? That seems pretty obvious that they do. And when I say reciprocal, reciprocal just means you're flipping the fraction. So if the tangent is opposite over adjacent, that means the cotangent would be adjacent over opposite. Okay, so if you need to write that out, adjacent over opposite. So the cotangent of an angle, cotangent of some angle, is the same as 1 over the tangent, and that is just the adjacent over opposite. Okay, likewise, the tangent of an angle is 1 over the cotangent. And this seems kind of silly to restate it, but that is going to come in handy throughout our whole trig experience, so to say. All right, so make sure you're comfortable with that. Now, what seems like what should go with what is not what should go with what. It would seem like cosine and cosecant would be reciprocals, but they're not. Okay, the reciprocal of the cosecant, which we would think goes with cosine, actually goes with sine. So sine is opposite over hypotenuse. Your cosecant is going to be hypotenuse over opposite. Okay, hypotenuse over opposite. So when we abbreviate cosecant, we write it as CSC. So cosecant of theta is going to be 1 over the sine of theta. And I know that you wonder, well, why? I don't even get why that's the case. It just is. You'll see as we go through different things with trig that trig functions have different relations depending on the concept that you're doing. With reciprocals, the cosecant and the sine are reciprocals of each other. Okay? Or you could say that the sine of theta is equal to 1 over the cosecant of theta. So that leaves us with secant. Remember, secant is adjacent over hypotenuse. And so if I were to take the reciprocal of that or flip it, that would be hypotenuse over adjacent. And so that would be secant, we abbreviate SEC. Secant of theta would be 1 over the cosine of theta, or cosine is 1 over the secant. So let's go back to our example problem here. We had 4, just change the color in here, 4, 3, and 5 as our sides. And we figured out what our sine, cosine, and tangent of theta were. But let's go back and do our cosecant of theta. So cosecant of theta, remember that just flips the sign. So if sine was 4 over 5, then the cosecant is just 5/4. Cosine in this problem was 3/5. So, oops, the secant, I didn't mean to write cosine there. The secant of theta then just flips cosine, so the secant would be 5/3. And the cotangent was 4/3, or excuse me, the tangent was 4/3, so the cotangent would be 3/4. As we said before, we said that with the sine and the cosine ratio, they could never be greater than 1 because the hypotenuse is the longest side. Well, that means that the cosecant and the secant cannot be less than 1 because it's the reciprocal of those functions. So remember that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. Okay, and make sure that you know which one goes with which and which does which, and you should be all set. All right, everybody, thanks.